Okay, great. Okay, guys, turn 2 is simplifying radical expressions. Oh, there's right there. So, fortunately for you guys, we live in California, so the word radical isn't such a bizarre terminology, but in math, it means the little symbol that goes over we use for square roots. So it's an expression that contains a radical or a square root. So that's technically, if you Googled radical, you may not get square root symbol in that.
So other places like states are still radical?
Correct. It is definitely a West Coast California thing. So Marissa, remember that while you're going to Australia.
What?
Radical is a West Coast
I'm gonna say
California thing.
Be like, well, that's radical.
I have several people that subscribe. I have over 100 subscribers to my YouTube channel.
Whoa! We should celebrate and get ice cream and cake.
Okay, so Georgie, let's see what rationalizing the denominator is. Okay, so let me just tell you, just like how in science, we don't really have a good reason that everybody doesn't use the metric system. So we use the English standard system of measurement, and everyone else in the world uses the metric system, and there's not really a good reason for it. Rationalizing the denominator is similar to that. You're going to get questions that will ask you to simplify the radical. If we don't rationalize the denominator, it is not technically simplified, and I have to mark it wrong. There was a thing in the 60s and 70s called the slide rule. A slide rule was the precursor to a calculator. So before they had calculators, you can ask your grandparents about that, they had slide rules. In order to use radicals on a slide rule, you couldn't divide by a square root. So therefore, we developed this system of rationalizing the denominator. And it still kind of hangs around like the English standard of measurement. So I'm sorry, it's a pain, but I have to teach it to you because it's a part of our standards, and they'll ask you to put things in simplest terms, and you'll have to rationalize the denominator. Okay, so what rationalizing the denominator is removing a radical from the denominator by multiplying the top and the bottom by that root. So if I have root 2 in the denominator, I'm going to multiply top by root 2, bottom by root 2. All right, so let's look at some properties of sequences. So we're going to use a factor tree to simplify. So I'm going to show you the factor tree way because it's like for me, I can walk to school, I can drive my car to school, or I can ride my bike, or I can take a scooter. There's several different ways I can get from home to here. This is the same kind of thing. We're going to do factor trees. If you don't like it, it's okay. If there's another way that works better for you, that's okay as well. So we're going to break 48 into its factors. And we're going to look for groups of 2. So half of 48, 24. Half of 24, 12. Half of 12, and half of 6. We're just breaking up 48 into its prime factors. If you have never seen a factor tree before, what you do is you start with the factors that you know, branch them off into those 2 factors, And then when something's a prime number, it gets stuck. So you circle all of your primes. And you break down 48 into its primes. So 48 is 2 times 2 times 2 times 2 times 3. We're looking for groups of 2. So that's 2 times 2 and 2 times 2. Technically, I have 2 groups of 2. So we know that there are 2 perfect squares, or 1 bigger perfect square, that lives inside of 48. So what is 2 times 2? So once you group them into 2s, you can go ahead and multiply those groups out. So check out 48. 48 is 4 times 4 times 3. I did the prime factors so that I could find the groups of 2. You can either put everything under one radical, and if you have multiply or divide, or you can break it up into its pieces. So this is the same as root 4 times the square root of 4 times the square root of 3. Sorry, I want to make that a nice 4 for you guys. What is the square root of 4? Which number multiplies by itself to give us 4? 2. So we can say square root of 4 is 2. Square root of 4 is 2. And we have the square root of 3. What's 2 times 2? So I think of it like this. If you are a perfect square, you get out of jail.
Really?
You get out of the square root jail. You get square rooted and put in the front. If you are not a perfect square, you get stuck in the square root jail. You don't get out. Just stay. So is 3 a perfect square? No, so he stays. Is 4 a perfect square? Yeah, so we square root them and put them out front.
I know.
Rachel?
So that's what make it like.
Yeah.
Here you go.
3 is a prime number and it's not perfect. Okay, so let's look at 32. We're going to factor tree 32. So that's 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. One, 2, 3, 4, 5 2s. We're going to pair them up. So once you get them in a pair, I'm going to write this as 4 times 4 times 2. Perfect squares get out of jail. Square root of 4 is 2. Square root of 4 is 2. Square root of 2, not perfect, still stuck in the root. Does anybody see an easier way? Like where we can skip about half of these steps? There is one. For those of you guys who can see it, I want to alert you that there is an easier way for these guys. If you don't see it, it's fine. Okay, so 63 is 3 times 21. 21 is 3 times 7. And all these are now primes. So this one gets to be, let's go 3 times 7. We group the pair together. Group the pair together. Oh, look what happened with the x, Gavin. 3 x's means x times x times x. I'm going to circle, or I'm going to group 2 of those x's together. So this is going to be 9 times 7 times x squared times x. All right. All right, so perfect squares get released. 9 is a perfect square. What times itself is 9? 3, so 3 goes out front. 4 square root of 7, he stays there. Not a perfect square, stays under the square root. What is the square root of x squared? X. So x goes out front, and poor little x, he is still stuck under the root. Let's circle the answers. So if there are 2 of them, we get to bring 1 out. It escapes. If it's not a perfect square, it stays underneath. So when we look at this, we're going to find the simplified form of these square roots. Okay, we're going to go square root of 160. So we're going to break that down into its factors. 80. 2 times 40. 2 times 20. 2 times 10, and 2 times 5. So that's 1, 2, 3, 4, 5 2s and a 5. Pair off our buddies, so groups of 2. So we're going to write this as square root of 4 times 4 times 2 times 5. What is the square root of 4? 2. Let's bring them out. And the square root of 4 is 2. And what is 2 times 5? 10. So the 2 and the 2 become 4, and the root 10, not a perfect square, doesn't even have a perfect square factor living in it, stays under the root. All right, let's try this guy. This is fun.
That doesn't look very fun.
So fun. When you have multiplying or dividing underneath a radical, you can split that radical into its parts. So I can write this as square root of 64 over square root of 49. What times itself gets us 64? Less than 100, yeah, 8. And what times itself gives us 49? All right, now you guys get a chance. 72 is kind of like this one we did here. Go ahead and factor tree.
Oh, it's
I'm going to give you guys just 60 seconds, 1 minute on the clock.
interesting.
So 72, when we break it up, so if you didn't know what half of 72 was, that's when you can use your calculator to help. Half of 72 is 36. Same thing here. If you didn't know half of 36, you can use your calculator to help you. However, if you put the square root of 72 in your calculator, it gives you an irrational decimal number, and that is not what they're looking for. They're looking for you to find the simplified form. So this is 2 times 18, 2 times 9, and 3 times 3. So that's 3 2s and 2 3s. So 2 times 2 times 2 times 3 times 3. We're going to group together the pairs. So this is 4 times 2 times 9. The perfect squares get to come on out. Come on over, guys. Square root of 4 is 2. square root of 9 is 3, and 2 is not a perfect square, so it stays inside. 2 times 3 is 6. We have 6 roots.
Is lunch next period? Huh? Is lunch next period?
Yes.
Yeah. I thought so was spring.
All right, so we are going to use more of, we're going to simplify it first and then fuss with the radicals. So this guy here, 54. Half of 54 is 27. 3 times 9 is 27.
It's Joffrey.
Hey, Jeffrey. Bye.
All right, so 54 is 2 times 3 times 3 times 3. X to the 7th is 7 x's. So we're going to write 7 of them. Then we're going to group it in twos. So there are 2 3s we can group together. And then 3 sets of x's we can group together. So this is going to be the square root of 2 times 9 times 3 times x squared times x squared times x squared times x. We're just kind of shuffling these little guys around so they're matched up into perfect squares. So what we're doing by splitting it all up is making sure our perfect squares are evident to us. Since 9 is a perfect square, we're going to take the square root and put it out front. Since x squared is a perfect square, we're going to take the square root and put it out front. And we're actually going to do that 3 times. Whatever's left is going to stay underneath the radical. 2 times 3 and an x. Wah, wah, wah. Poor guys, look how sad they are in their square root prison. Boo. So this is 3 times x cubed times the square root of 6x. Perfect squares, come on down. Everybody else stay inside. Sad panda. Okay. Take a look at these. Do we do exponent rules, guys, where we subtract the exponents if they have the same? We divide and we subtract the exponents. If they're multiplying together, we add the exponents, raising the power to another power.
Yeah.
Okay. I did it in geometry as well, so I don't want to make sure what you guys do. Okay.
Yes.
True or false? 8 over 50 simplifies.
Actually, I don't think there's one.
Are they both even? Yeah, so I'm gonna reduce that.
Hey, you don't want to.
The 3x's on the top and 1x on the bottom is x to the 3 minus 1. What is 3 minus 1?
3 minus 1 is 2.
It is 2, so same as x
12 minus
squared.
I've been practicing my addition.
Good job. So what is the square root of 4?
2.
What is the square root of x squared?
2.
What is the square root of 25?
5.
All right, you guys give this a try. 80, split it up, and then m to the 9, split it up. So let's pair together these guys here, these guys here, and 4 pairs of m's. 4 times 4 times 5 times m squared times m squared times m squared times 1 lonely m squared on its bad self. Okay, what's the square root of 4? So square root of 4 is 2. Square root of 4 is 2. 5 is not a perfect square. He stays inside. Square root of m squared is m. Square root of m squared is m. Square root of m squared is m. And square root of m squared is m. Everything that didn't get circled in blue stays inside my square root. So that's 5 times m underneath the square root. Now I have to combine all my m's and my numbers together. What is negative 2 times 2? Negative 4. Because it already had a negative to begin with. So that negative just stays in the front. What is m times m times m times m times m? There's 5 of them.
Oh yeah, there's a negative one.
4, 5, and m stuck in their square root prison. So now we're going to take a look at when we're multiplying other radicals by radicals. So if it's a radical, we can move everything that's under a square root under one giant square root. So if it's not under the square root, it goes out front. That's like this 2 and the 3. If it's underneath a radical, we're going to put it under one radical altogether. So that's the 7 and the x and the 14 and the x squared. So you guys, this is going to seem crazy, but we're going to combine it together, then we're going to separate it back out. So 2 times 3 is 6. 7 times 14, I actually know this one, it's 98. X times x squared is x to the 3rd. So now we're in the scenario where we were here. We need to, like in this case, we need to divvy up that 98 and then I know 98 is 2 times 49. 49 is 7 times 7. So this is going to be 2 times 7 times 7. And this x to the 3rd, it's just 3 x's. Let's partner up. Whoever has a buddy, a little matcher, 7 times 7 and x times x. We're looking for the pairs. So this is 6 square root of 2 times 49 times x squared times x. 49 is our perfect square. What is the square root of 49? 7. I already have the 6 out front, so I keep the 6 out front here. X squared is a perfect square. What's the square root of x squared? X. Okay, and then the 2 and the x stay underneath. 6 times 7 is
975.
42? Yeah. Got it. Nailed that one. Okay. So after I combine, I know it says now you try. I'm going to do the first two with you. And I'm going to show you how, if your brain thinks in terms of factors, like in this class, Layla's super good at factors. So if your brain thinks in terms of factors, then I'm going to show you a way to get your perfect square out of the factors. So if it's on the outside, it stays on the outside. Otherwise, it goes on, if it's under the root, it goes under the root. What perfect square lives inside of 18? So think about the factors of 18. And we want to compare it to the perfect squares. So think about this. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, thank you. 64, 81, 100, 121, 144, 169, 196. Okay, so these are perfect squares. So if we know that 4, 9, 16, 25, 36, or 49 is a factor of what we got going on in here, then we don't have to do this pairing part. It's a way to kind of, 49, it's 7 times 7. If you already can see that, you don't have to do the pairing part. If it doesn't come natural to you, don't feel bad, it's fine. You can do the pairing. So I know that 9 is a perfect square that lives inside of 18. What I don't know Six breaks up into 2 times 3. I'm going to leave the 9 kind of on the end. So 6 is this 2 times 3. 2 is going to partner up with the 2 from the 6. So now we're going to start sharing factors. I'm going to leave 9 out. So we got 4, we got 9, and we got 3. Square root of 4 is 2. The 3 stays out front. Square root of 9, 3. And then 4 little 3 doesn't have a perfect square. 3 times 2 is 6. 6 times 3 is 18. All right, I'm going to give you guys 60 seconds on the clock. I want you to try these 2 problems, and then we'll come finish them up together. All right, so for the first one, I kind of skipped a step, so if it blows up your brain, you don't have to skip the step. A to the 1 times a to the 3 is a to the 4. A to the 4 you can break up into a squared and a squared. So instead of writing 4 a's all out, buddying up 2 together, I just wrote a squared and a squared. 2 times 9, 9 is a perfect square. The square root of 9 is 3. And then square root of a squared is a. The square root of a squared is a. When I combine these 2 together, I get a squared. And 4, 2. He is not a perfect square. He gets a J in square root jail. Looking at the last one. If it's out front, we just go ahead and combine them out front. Okay, so 20 is 5 times 4. So 5 times 5 is 25. That's a perfect square. 4 is a perfect square. And any exponent that is even is a perfect square. Any exponent that's even is a perfect square. So if I have this is brand new stuff. If I have an even exponent, I just cut that exponent in half, and that's what I get when I take the square root. So x to the third times x to the third gives me x to the sixth. So the square root of x to the sixth is x cubed. So what's the square root of 25? 5. Square root of 4, and square root of x to the 6th. Cut the exponent in half. 5 times 2 is 10. 10 times 21 is 210. Woo! All right. So we're going to bring back the quadratic formula. I think I wrote them on the board right here. And those of you guys who are doing your test, this will help you because you'll need to be able to do quadratic formula on your test. So in this problem, if ax squared plus bx plus c is our polynomial, equals 0. Negative b plus or minus square root of b squared minus 4ac all divided by 2a is our quadratic formula. What's a for this problem? A is 1, b is negative 6, and c is negative 4. Okay, so in this formula here, some of you guys really struggled with this on the test, so watch and learn. If it has a negative out front, that negative gets written. This negative b, that negative gets written. If b is also negative, you're going to end up with a double negative. But if you skip that step, some people skip it and do it wrong. So I just put the minus negative there to make sure I don't skip any steps. Plus is one of the answers. The minus is the second answer. And then we're going to b squared it. When I have a negative number and I square it, I end up with a positive. 4, no matter what, it's a 4, times a times c, all divided by 2a. We're going to simplify. This is where we say it's no skin off my nose to write the minus negative because I'm going to do several steps of simplification anyway, so it'll help me just keep track. Minus a negative is the same as plus, so that's positive 6, plus or minus negative 6 times negative 6 is 36. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. 2 times 1 is 2. Some of you guys also missed this part here. It's a minus sign here, and then the answer you get out will be negative. Minus a negative is plus. Okay, simplify this again. 6 plus or minus the square root 52. I love 52 because that is the deck of cards. A deck of cards is 52. So we can easily break 52 up into like 2 and 26 and 2 and 13. So 52 is 2 times 2 times 13. What perfect square lives inside of 52? 4. So this is 6 plus or minus square root of 4 times 13. We're going to go ahead and take the square root of 4. It's going to come out and be 2. And poor root 13, he's going to stay there. I'm going to split my over 2 because you guys, you know, if we have a common denominator, we can add or subtract the top and leave the common denominator. We're going to kind of go backwards on that. I'm going to split that 2 up into each of the pieces. So this is going to be 6 over 2 plus or minus 2 root 13 over 2. What is 6 divided by 2? 3. And what is 2 root 13 divided by 2? 'So the simplified form, if I have 2 root 13s and I cut them in half, I have this one. So the answer is 3 plus or minus root 13.
Is there an easier way to do it?
You don't, once you get good, you can skip steps, but at this stage of our learning, we have to do, it's just simple multiplication and division, so. All right, so you guys, we're going to do that same process. Identify the A, the B, and the C. Put it into the Pythagorean theorem. And then simplify it down. All right, so let's plug it in. -2 plus or minus 2 squared minus 4 times 3 times -6 divided by 2 times 3. -2 plus or minus, this guy is 2 times 2, which is 4. -4 times 3 is 12. -12. -12 times 6 is positive 72. 2 times 3 is 6. 4 plus 72 is 76. Divided by 6. Need to find the little factor tree. 38. 36 times 36 is, or 36 plus 36 is not 76. 38, half of 38 is
97.
And 19. Wait,
Yeah.
this is 2. Sorry. So 76 is 4 times 19.
I thought 72 was negative for some reason.
And square root of 4 is 2.
4 squared. I don't myself.
Which bucket?
Here's the whole thing.
76, true or false, 4 times 19. Okay. What's the square root of 4? So go ahead and bring that out. 19 stays underneath.
Is it pretty nice?
Now, we're going to split this up.
Sweet, it was my birthday or something.
And simplify the fraction. 2/6 is the same as 1/3. 2/6 is the same as 1/4.
Miss, Doge.
Yes, that's Morgan.
Her name's Morgan.
Uh-huh.
Morgan, you're on the board.